Hello, hey everybody out there in Twitch land. This is David Daniels here with AWS Howdy Partner. I'm here with my co-host Tiffany. How you doing, Tiffany?
Hi everyone. Good, David. How are you?
I'm good. I think you were frozen there for a minute.
Am you moving now?
Oh, you're moving a little bit better now. We'll see how it goes. Yeah. So anyway, welcome to AWS Howdy Partner. Howdy Partner is our show that we have every week on Wednesdays where we bring in some of our partners and show you some of the cool and awesome solutions that they're doing and let you guys have a look at some of their demos, and they talk through everything and gives you an inside look at some of our partners and what they're doing. So a lot of fun stuff. Today we're really excited to look at some really cool data privacy stuff. So yeah, super excited. Tiffany, what is it that you do again with AWS?
So I'm a solutions architect. So I work with customers and partners on, talking about architectures, best practices, etc.
Cool. You work with a lot of like data privacy stuff.
Yeah, with my different partners. I know security and data privacy is definitely something that we take as a priority at AWS, and our customers do as well. So I think everyone will be really interested in hearing what our partner today has to talk about.
Sweet. Yeah, I know I'm excited. So without further ado, let's go ahead and bring them on. We've got our friends from Skyflow here with us today. We've got Sean and Ashley. Sean, Ashley, welcome to the show.
Thank you. I'm excited to be here, and I was excited to be described as cool and awesome, or at least our company as a partner to AWS was described that way.
Yeah, definitely. I think I describe many things as cool as awesome. Those are some of my favorite words, but I genuinely mean it. With what I've been reading about you guys, seems to be a lot of interesting stuff. So I kind of browsed through Skyflow a little bit on my own, and seems like some fascinating stuff. I'm really excited to get a little bit more details on it.
Awesome.
So to start, I guess, can you guys introduce yourselves? You can introduce yourselves on a personal level, and then introduce Skyflow and what it is you guys do for them and your mission.
Ashley, do you want to start?
Awesome. Yeah. Ashley Joe's here, product lead at Skyflow. Joined the company around 3.5 years ago as the first product manager. Back then, we were around 12 employees. Now we are over 100. So it's been a huge growth for us.
Sorry, you said the first.
Like the first product manager. Yes.
That's awesome.
Yep. Prior to this, I was at Salesforce working on the platform team as a PM as well. And before that, I was at MuleSoft for around 4 years, working on several different initiatives, both mainly in the PM side of things. And MuleSoft went public and was acquired by Salesforce, and that's how I landed at Salesforce. At Skyflow, I work on mainly two large-scale initiatives. So one is governance, which is basically how do you protect access to sensitive data in the platform. And the second part of it is secure workflows, which is how data flows in and out of the platform. And we can go deep into those things today. So excited to be here.
Awesome. And I'm Sean Falconer. I'm head of marketing and developer relations at Skyflow. I've been here for about 2 years. And before Skyflow, I worked at Google doing kind of a mixture of stuff, product, engineering, developer relations. And before that, I was a founder of a company. And at Skyflow, I'm responsible essentially for the marketing side of our go-to-market, but I also do a lot in terms of sort of developer education and content creation for developer communities.
Awesome. Well, thank you guys for joining us. And so what is it that, I guess, what is it that Skyflow is doing? What are the solutions that you're going to be showing us today? And I guess just a brief overview of how that all began.
Yeah, I can start. Maybe I'll give a brief overview, and I have some slides that kind of show. I don't want to spend too much time in the slides, but some things are just easier to kind of show through pictures. But essentially, Skyflow is what we call a data privacy vault, which we make available as a service. And one way to kind of think about that is it's like your core. It becomes your core infrastructure for sensitive customer data, or PII. So instead of essentially using and relying on traditional systems like your databases and other places where customer data may end up replicated and kind of you end up with a sprawl problem, you're moving that into this isolated, protected environment that is designed to give you security, usability, and governance over that information. So it's not just about securing it, but actually allowing you to use that information in a privacy safe way. All right, so I'm going to jump into slides and we'll kind of dive into this a little bit more. And feel free to jump in with questions, of course, as we go.
Yeah, excellent. Absolutely. And everybody in the chat, feel free to throw some questions in the chat. Let us know where you're watching from. I love seeing how Howdy Partner has gone international a lot of times. So I'd love to see where y'all are watching from.
All right. I'm assuming my screens are up. My screen is up.
Yeah, I am adding it right now. There we go.
All right. So we kind of, we've touched on this a little bit, but essentially what problem is it that we're trying to solve? And essentially the problem is, illustrated here. Go to the Google News, whatever your news feed is on any given week, and you're going to see essentially headlines like this where, major corporations, everything from, in this case, essentially major hotels and casinos to large scale tech companies really having a hard time in terms of protecting customer data. And sometimes that's through data breaches, sometimes it's through actual, cyber attacks, sometimes it's through accidental leaks and so forth. And they're also navigating all the challenges around the sort of ever-evolving privacy regulations around the world. And this is something that, regardless of how much money people are sort of pouring into trying to solve this problem, we're still seeing it over and over again. These are like very well-resourced companies that are still struggling with this problem. And I think a lot of the problem sort of comes from sort of a fundamental sort of mismanagement of data, of how we've traditionally organized information. So as a simple example, here is just kind of the high level overview of any modern system where you have an application front end, gateway, sort of back end services, downstream to database, data warehousing, and so forth. So if we take an example of collecting something like someone's phone number or any kind of customer data, what we end up doing in a traditional system is we pass that information downstream, creating essentially storing it in a database, storing it in the warehouse on purpose, but potentially it ends up in log files and also the backups of these systems. So kind of what I was talking about in the beginning there is we end up with this huge sensitive data sprawl problem. So instead of having like one copy of the data, we end up with thousands of different copies of the data, potentially, depending on the size of the system. So it's a little bit like instead of having, your passport where you have one copy of your passport in a secure location in your home, imagine if you made like 10,000 copies of your passport and then put them all over the place and then try to protect all those locations. Like that is a much harder problem to solve, but that's essentially what we've historically done with customer data. And it just becomes essentially an intractable problem because over time, companies just lose track of like what they're storing and where it's stored. And if you don't know what you're storing and where it is, it makes it very hard to protect. It makes it hard, basically impossible to make sure that you're compliant with regulations and that you're actually ensuring people's privacy. So what people end up doing or companies end up doing is they kind of try to apply a bunch of like band-aids to this through sort of chicken wire and duct tape. So they take, they might add in some encryption at certain places. They might apply certain access control levels at the database, but it's hard to do that holistically across the system. And it's a little bit like putting like a band-aid on a broken arm, essentially. So the big question is like, how do you solve this problem? And there are a number of companies that sort of recognize this problem and pioneered this idea of a zero trust PII data privacy vault. So companies like Apple, Google, Netflix, a handful of others that are shown here, they recognize that essentially sensitive customer data or PII is something special. It needs to be treated as something special. So they needed to develop specialized technology for handling it and move that out of their core systems. So they took their customer data, or at least for certain workflows, and they moved it into these zero trust PII data privacy vaults, and then effectively descopes their existing systems from essentially the responsibilities of data security, compliance, and privacy, and creates this single source of truth of their customer data. And then last year, the IEEE came out with this article about a year ago, actually, that talks about the future of privacy engineering and how the future of privacy engineering is this approach of moving beyond privacy by design to privacy by engineering through this new architectural approach, which is the data privacy vault. So the article essentially is elevating the concept of the data privacy vault to the same level as any kind of architectural pattern that you see here, like these kind of core components of any modern system where we have, databases, data warehouses, ETL, backend, whatever. Essentially, the data privacy vault, according to the IEEE, is the recommended approach for how you store, manage, and use sensitive customer data. So we've been essentially taking this idea and making it available as a service. So all those different companies that I mentioned built these as proprietary systems within their own companies, but we've essentially built that privacy vault available for anybody else. So the big part of our thesis here is that the same way that encryption keys, secrets, passwords, these types of data are sort of special, and we treat them differently than regular application data. And we essentially leverage new types of technologies like a KMS, secrets manager, or, identity cloud for purposely managing and storing this information outside of our existing system. We essentially need to fill in this box of what do we do with sensitive PII data, and the answer to that, essentially, according based on our point of view, and as well as sort of backed up by the IEEE and some of these other major technology companies, is the solution to that is this PII data privacy vault pattern. So what that means for going back to the system with problems is that when where essentially we're losing track of what data we're storing and where it's stored, which leads to all these sort of fundamental problems with the management and security of the data, things get simpler when we introduce the data privacy vault. So in the vault architecture applied to the same sort of flow, what we want to do in the ideal scenario, and we can talk about different ways of sort of integrating this, but in the ideal scenario, we want to de-identify the data as early in the life cycle as possible. So that's essentially at collection. So we can take someone's phone number, move that into the vault, creating this single source of truth of that customer data. And the vault is essentially going to be responsible for securing it, isolating it outside the environment, but it also creates essentially a reference, kind of like a pointer, in the form of a vault generated token. So we'll probably touch on LLMs at some point. So this is not an LLM token. This is a vault token. And essentially what this is there's no sort of mathematical connection between the original data and the vault generated token, but this is a stand-in for that original value. And there's lots of ways we can get into with what we provide from Skyflow, where we can generate these in a variety of different formats and consistently generate to support various workflows. But essentially what we're doing once we've done this is this de-identified reference gets passed downstream. So we end up with that in the database or the data warehouse and potentially in the log files. But that's okay, because if any of these systems get compromised, there's no way to reverse engineer that token back into the phone number. And and having a bunch of the tokens doesn't tell you anything about, mathematically how those are essentially being generated. So what we've done is we've essentially de-risked this entire surface area from the responsibilities of data security and compliance, because it's not actually handling any of the data. It's only handling this anonymized forms of data. And we can still essentially leverage both the vault and our internal systems to share data with third parties. And we'll get into a bunch of this stuff when we dive into the demos. And so that's kind of the first piece of it. But really, a lot of this comes down to, and what, a big part of what Ashley's responsibilities is around like controlling who sees what, when, and from where. So it's one thing to essentially replace the data with tokens, but ultimately, how do I know that, someone in customer support is going to be able to see one version of the data in order to support their workflow versus, somebody in marketing versus the CEO of the company? And then how do we essentially do that in a compliant way for things like data residency? So essentially, the Skyflow Vault facilitates all these different types of workflows that you need to do with PII data without actually you sort of being exposed to it. And that includes, essentially deploying vaults to different regions to satisfy data residency requirements, and descoping existing services, whether that's a CRM, like a Salesforce or HubSpot, Zendesk, or even your warehouse solution, like a Snowflake, Databricks, Redshift, and so forth. All right, so I'm gonna pause there before I jump in the demo. Any questions about what I was just discussing?
Let's see, I don't see anything in the chat. If anybody's got any questions, throw them in. Feel free.
Ashley, do you have anything to add too?
No, I think you covered it really well. So I think the core thesis of the company is built on the fact that all data is not created the same, and there's specific kinds of data where you don't necessarily want to store with the rest of your data. So things like, your customers' social security numbers or credit card information should not be stored with analytics data and so on. So basically what we have done is provided a secure way to store that data and also make it usable at the same time.
Yeah, exactly. All right, so let's get into some demos. So the first one I'm going to show is just a simple demo that shows how some of the governance works, and then we'll actually dive into some of the back end and the API to kind of show how would you build something like this. So here, what we have is a sort of the representation of a vault over here on the right with a bunch of like customer data. And the vault, as I mentioned, is zero trust model. So essentially, no thing has access until you explicitly give it access. And you build up access through essentially creating policies that dictate which sort of tables, columns, rows either the person or the service have access to and how they can see that information. So you can see an example here. So this is someone with a marketing role. These are the policies, and then this is essentially the what we would see in the as a result in the vault. So they can see the name, they can see email. They don't need social security number for doing marketing. They know the birthday because maybe they need to send the person a birthday announcement or something like that, but they don't need to know how old the person is. And then they see state, and essentially that's controlled through the simple policy language. And one thing to note here too, and we'll get into the details during some of the demo when we dive into the APIs and so forth, but a big part of our sort of secret sauce is how do you essentially secure the data but still keep it usable? And the way that we were able to do that was essentially developing a technology that we call polymorphic data encryption, which allows you to not only store data encrypted during rest and during transit, but actually perform operations like encrypted operations on the data and keep it fully encrypted. So something like this, where we're pulling back the date of birth, this data is actually never essentially decrypted and then some sort of dynamic mask is applied to it. The year here is never actually in the clear based on this policy and control because of polymorphic data encryption. And then if we look at customer support, here we have, even less access to information. So we have like name, last four social for validation of identity, perhaps, and state. And then you'll see here a lot of rows are basically inaccessible. And that's because there's a row level restriction so that this customer support agent actually can only see data for people who are in the state of Arizona. And the big thing here is that, especially from like a privacy standpoint, but also from a security standpoint, is you want to focus on the data minimization and only giving people access to based around the minimal amount of information they need to be able to do their job. So if you think about a customer support agent, or even some of the data breaches that happened like a couple of years ago, the Robinhood data breach, where someone was socially engineered into giving up on the customer support side, giving up their credentials. Those things happen, but then the attacker got access to like 6 million records. And there's not really a reason why a customer support agent at any given time needs access to 6 million records. Realistically, they probably only need access to the number of customers that are in their queue at any given point. Maybe that's like 6 people, and only the limited amount of information they need in order to do their job to help that person. So by essentially applying this sort of pattern and also this way of thinking, even in the worst case scenario, in the case of like a data breach, you can significantly reduce the scope of damage that would happen. All right, so let's jump over here to Skyflow Studio. So everything.
Hey, Sean, before you do that, can we get to a couple questions here? I see in the chat.
Okay.
So Hartstead is asking, do most companies have an outside agency that makes sure they are being responsible with user data? And that is not a dumb question.
Ashley, do you want to take it?
Yeah, it's definitely not a dumb question. So I think it depends on the type of data. So when you look at like the fintech space, there's a regulation called PCI data. In the healthcare space, there's a regulation called HIPAA. And all these regulations have certain criteria in how, when you're storing this kind of data, which is basically patient information or credit card information, there's all these sort of controls that you need to follow in order to store that data. But if you're a startup, if you're a company embarking on this journey to store this data, it's a lot of effort to store, even to start your business, right? So that's where a company like Skyflow can help, where once you store this data with Skyflow is by default helps you get compliant, because you're basically taking off the data that you must be storing in your database and putting in your Skyflow. And Skyflow has all these different controls that helps you get compliant faster. So it makes it very easy for you to get to that state of being compliant with these regulations.
Does I guess so? Does Skyflow like kind of handle like the compliance side? Like if I was a company I went to Skyflow, like I no longer have to worry about compliance at all? Like, is that kind of how that works?
You still do have to worry, but you'd have to worry less. Let me put it that way. So
Fair enough. Fair enough.
basically, you're just reducing the scope, your compliance scope.
I see another question in the chat too. Does it take significant amounts of refactoring in order to take advantage of the vault? Looks like the vault in some ways is another data source that we need to connect through the poll data. So that's a great question. It's also a question we get a lot. So I think it depends on the situation. So of course, if it's like a net new project or your new company, then you can sort of build from the beginning, build this into your architecture. And we have lots of customers that do that. If you're a larger customer where you have this huge sprawl problem where your data is in 10,000 places, typically someone isn't going to like essentially re-architect from ground zero. They would do something in stages, similar to like, if a company wants to modernize and move from on-prem to cloud, like I think Netflix took like 8 years to do that. They didn't just like shut down Netflix and then do that migration and then pop up 8 years later. They took new projects, moved it onto the cloud, and then sort of, moved backwards from there. And one of the patterns that we typically see is either, even big companies like an IBM or something like that, they have net new projects all the time. And it might make sense for them to leverage, Skyflow for that. So like Lenovo is a customer, for example. They're a big company. They use us for essentially a data residency. So they were launching essentially a new laptop in 20 different countries. 6 of those countries had data residency requirements. So how can you essentially do that all at the same time without cloning your infrastructure to all those different locations? And they were able to do that in a very short order by essentially deploying vaults to serve those locations. So it can actually speed up your go-to-market depending on the problem that you're trying to solve. And another pattern that we see is a lot of times older companies that maybe were running on-prem that want to modernize, move to the cloud, a lot of the first workloads is essentially around analytics and warehousing. So they want to, you could be a big bank and you want to move essentially to using a modern, Redshift, Databricks, Snowflake, something like that. And you want to enable your analysts to be able to do their job, but you don't want to just like move all your banking, customers' banking data into those systems because they don't need to be there in order for the analysts to do their job, but they need enough data to do the thing that they need to do. So you can essentially plug Skyflow in as part of that ETL process. And this is some of the work that Ashley does around like secure workflows of essentially sitting at the head of the ETL process, making sure clean data that you can still run analytics on is going into those sources. So you can take advantage of these modernized systems without essentially, compromising privacy or accidentally leaking something to your analyst team.
All right.
Great
awesome.
question, though.
Cool. Thank you. Keep throwing them questions in.
All right. Should we get here? We'll go back to the demo here. So this is Skyflow Studio. So everything in Skyflow is API first. So everything I'm going to show you can do through APIs, but Skyflow Studio is also our web-based sort of platform for managing vaults and doing a lot of the like sort of infrastructure management. And if it's better to demo than me just running curl or commands to the APIs. But what we have here, essentially, we can go ahead and like start by adding a vault. We'll take a look at creating a custom vault. So we'll just use the default there. So at the beginning, a vault is schema based. So you can have tables. We can create multiple tables. We have essentially columns and rows, and I can go ahead and create a new column, and I can create a column. And this stuff's going to look very familiar to anybody who's ever designed a database, but you have strings and integers and date times. But where this starts to essentially be different than just a database that's running somewhere else is the vault also provides support and understanding of essentially what we call, in this case, Skyflow data types or privacy preserving data types. So every type of PII, regular type of PII, essentially the vault understands that type of data and gives you a lot of defaults that allow you to facilitate the types of workflows that you want to do it. So when we think about PII, for example, something like a social security number or a phone number or a credit card number, like we call these things numbers, but in reality, they're actually data structures. And essentially the different components, they're made up of different components. So think of a phone number, an Americanized phone number. You have, a country code, you have an area code, you have, a local code. And each of those things are important for different sort of workflows. you might want the country code or maybe even the area code for performing some sort of analytical operation, whereas you might want the last 4 for validation from a customer support agent. And what the vault can do is understand actually the phone number essentially as an actual data structure and facilitate all those different workflows. So we can look at something. Let's take a look at email, I guess. So the email here, as the first thing, it has a regular expression that validates that this is actually an email, looks like an email. There's, sort of normal things that you might configure for a database in terms of unique and required. Any of the data that goes into the vault in terms of an email, then we can essentially create a vault generated token that we're going to safely save on essentially our application side. So there's different ways of persisting tokens. In this case, the default is a consistent token. So that means that my email, seanfalconer@skyflow.com, will consistently be tokenized as abc@gmail.com. And every time that information is countered, it's going to essentially generate the same consistent token. And that's helpful when we're doing certain analytical operations, because then we can still do counts and groups and joins on essentially the token as long as it's consistently generated. And essentially, you can make it also format preserving. So if I have downstream services that are depending on something looking like an email, looking like a phone number, and I want to preserve that, I can do that essentially by enabling this.
And I think that's an important feature as well, because I think bringing back to the previous question, so if you have a format preserving token, your email, the token which is generated when you insert an email, also looks like an email. So when you're storing that in your database, you don't need to change the schema. Kind of looks like an email. So yeah, it's one of those many features that we help make it easy for you to integrate with existing systems.
Mm-hmm. Yeah, and there might even be places where, with like credit card numbers, where you do want to do sort of like bin, you want to preserve the bin number, but randomize everything else so that you know who the issuer was. So that's not necessarily leaking information other than understanding who the issuer is, for example. And then under redaction, essentially you can control how the information could be displayed. So you can make it fully redacted where no one's essentially going to have access, partially redacted based on a pattern. So in this case, email is going to be my email, seanfalconer@skyflow.com is going to be S, a bunch of stars, and R@skyflow.com. Or we can turn off redaction if it's non-sensitive. And then the last thing is encryption. So of course, like everything's, encrypted during transit, encrypted, at rest. But as I mentioned, through polymorphic data encryption, we can also support encrypted operations. So for like strings, we can do things like, an exact match against fully encrypted data. On things that are integers, we can do aggregates like averages and sums and comparisons. So we could even run an analytical query like group or what is the average spend of our customers by group by state, and essentially run that analytical query against the vault and compute that report without actually decrypting any of the information. All right, so that's a little bit about essentially creating a vault from scratch. So we could build that up, and this could essentially mimic where you might be storing this data today in a database, but you're going to essentially replace the raw plain text data with essentially tokenized versions of that data if you wanted to have a copy on your end. And then let's just go back here to, so we can build that up certainly from scratch. We can also start with a template. So there's certain workflows that we support, common workflows like payments, for example. We can take a look at this. So the payment vault essentially just gives you a scheme out of the box to support like a payment workflow. So this is like, transactions, credit cards. And it's like just a place that like, I can hit create vault. It's going to be generated in 30 seconds. And I have this table structure that can kind of get me off to the races. And I can use this as a starting point. And I can modify it or remove things as needed. And we have a couple other ones here. So what we're going to take a look at, though, is what we call the quick start vault. So the quick start vault has a credit cards table, and it also has a persons table. And it also has a bunch of fake data within it. So it's essentially a learning tool for people who are learning how to use Skyflow and learning how to integrate with it. So we have, a bunch of credit card data in here. And as the vault owner, in this case, or vault creator, I see the data, but I'm still only seeing essentially the cardholder name as redacted, the card number, I see last 4, expiry month, expiry year. And then we go in persons table. I kind of, I'm redacting the name, email, and then some of this data is masked. And I can even run like a SQL query here. So I can say like select star from persons where state equals California, where Ashley and I are. And because of polymorphic encryption, I'm running that query and getting these results back without actually decrypting anything. All right, so let's go back to the default view. So that's just a little, sort of quick introduction to the vault. I'm going to jump over. Next, what we're going to look at is sort of how some of the APIs work. And then we'll get into modifying creating a policy essentially to restrict access, similar to what we saw in the governance demo. So I'm just going to grab my API key here and go over to Postman. So every vault, you can download a Postman collection for it. And essentially the Postman collection has our data APIs. So each table has CRUD operations, gets and inserts and deletes and so forth. There's also tokenization API and a query operation API. So this is where you can run like a SQL query essentially directly against the vault. So we do something like get bulk persons here. And we just take a look at what that looks like. We're just doing a get essentially against the vault. This is the vault ID in the person's table. If you've ever worked with REST APIs, this should not be particularly surprising. And when we run that, we're getting back the JSON records, similar to what we saw when we were looking in Skyflow Studio. And I can also take the Skyflow ID here. Oops. Let's copy that. And I can do singular restrict this call to getting a singular record. And here all we're doing is essentially doing a get with restricted to the person ID, execute that, and then getting a singular record. And I can delete this information, insert new records, and so forth. It's types of things that you would expect. So I'm going to go back to the vault here. And what we're going to do is we're going to set up some new access control policies. So I'm going to go ahead and add a new role. And I'm going to call this, we'll call it Arizona Customer Support. Create this. And I'm going to, right now, this role has been created, but it doesn't actually have access to anything until I create policies that grant it access. So we're going to go ahead and create some policies here. And I've already done this somewhere else. So we'll just copy those in and I'll explain what's going on here. So what I've done is I've created 3 different rules here. So I'm allowing read on the name, Skyflow ID state, and I'm letting that be in plain text, and I'm restricting by the doing a row level restriction on the state of Arizona. I'm giving read access, but masked to date of birth and social security number, and then I'm redacting the email. I'll go ahead and create this. We'll just say unknown. I'm going to enable that. And so now we have a role in a policy. So next, what we need to do is give essentially a programmatic access to this role in policy. And we do that by creating a service account. So I'm going to create a service account here, and we'll call it Arizona Customer Support. And then we'll, this is all fine. We'll select the resource here, the Quick Start Vault. I'm going to assign this role. And then I'm going to create that service account. And it's going to download a credentials.json file to my local machine. And that contains essentially the private key that I'm going to use to sign a JOT token to generate an off-bearer token. So I'm just going to go ahead and generate that off-bearer token with a script behind the scenes here. And now with that, what we're going to do is we're going to go back to Postman, replace this off-bearer token that I pasted in originally that gave us kind of full access, read access to the vault. And we can go and execute the exact same API call. So you can see here, this is like Texas. And what should get back here is only, and then what we see here is we're only getting the records in Arizona. So I see these 2 records. There's only 2 in the vault that match the state of Arizona. And if I go back to this get persons call, you can see this person's in Texas, run the exact same API call. And now I'm getting 404 no records found because this essentially service doesn't have access to these based on that row level restriction. And I haven't had to go and deploy anything, make a different API call. It's all based essentially on the mapping of, the how that authentication is happening and the mapping to the role in the policy. And I can even go back here. Let's go back to the role, view this. we'll edit it. And let's say we decide that we don't want the person to have date of birth access for whatever reason. Our requirements change. I can just save that. And now, again, without sort of deploying anything new, exact same API call. Now I've restricted access on date of birth, so it's redacted. All right, I'm going to pause there and see if anybody has questions.
We've got a question in the chat from a Doe Bofus. Is this all API driven, or is there MySQL engines or such that you connect with, or both?
So it's primarily API driven, but we do connect with data warehouses like Snowflake, Databricks, and BigQuery through user-defined functions. And I think in the future, we'll probably also have connectivity to direct databases too. But most of our customers currently use it through our REST API interfaces.
Or SDKs.
Yeah.
Good question. All right, so I'm going to set up the next demo here. So Ashley, if you want to just filibuster for me while I log into some things and get
No, I
this set
think
up.
what you showed right now is pretty cool. So I can talk to a little bit about what happened behind the scenes, right? So one aspect of it is when you set that policy, one unique aspect of Skyflow is we have that relational nature of the vault. So we know what an end user record is and what are the different columns or fields associated with that end user record. So we know we have a good understanding of a person's phone number, SSN, and so on. So because of that, it makes it very easy for us to have column level access controls. So you could say you get only access to someone's phone number. And even when you get access to the phone number, you can specify whether it's the entire phone number or is it just the last 4 digits. So those are some cool things we can do there. The other thing is, I think, very unique to us is also row level security. So it's not just that you have access to certain columns, but also at the row level. So what's happening behind the scenes is when that request comes in, there's a dynamic filtering that's happening behind the scenes. So it gives you access to only those records which your policies gives you access to. So those are some of the techniques we use to really give you fine-grained access to the data that you only need to have. So typically, if you don't have these controls in place, what happens in many production systems is the customer support agent has access to the entire customer database. There's no principle of least privilege access enforced. And those are one of the main reasons why we see all these breaches out there in the market, where have expanded your attack surface area.
So Ashley, who would you say your typical end user is for Skyflow? Would it be the customer support agent or the middle person who's managing all of these permissions? Who are the typical personas that you see using this product?
So our end customer is again a B2B platform, right? So we sell to other enterprise companies. So the end user here could be the actual customer themselves accessing their own information. So it could be a profile page and they're trying to view their own profile. It could be a customer that's trying to run a payment transaction, right? So they want to purchase something. So one of the largest buy now, pay later solutions in Europe is using us, right, for storing all credit card information and processing their credit cards with Stripe. So we see a lot of any B2B enterprise customer that has a need to store sensitive data, whether it's PII, PCI, or HIPAA. There is some value to be had of using something like a Skyflow in place there. But the end personas could be their customers, right? So it could be the end users, it could be support agents, it could be admins, it could be data analysts who are running these queries in data warehouses and so on. So
yeah, essentially our customer is a business, and then the person doing the implementation is going to be essentially an engineering team, but then it's their customers that data that ends up ultimately in the vault, or it could be, depending on how they define it, could be partners, essentially anything sensitive. So there's regulated data, but then there's also just data that you might not want, showing up on the front page of New York Times because of the data breach, that you might also want to essentially put into the vault architecture rather than relying on existing systems to secure it.
It looks like there's another question in the comments by Dobofus. When you deal with, say, many agencies, does the access roles get complex? Is there a way to build reports on those roles?
So we don't technically deal with many agencies. So it's the responsibility of the customer to certify compliance. So they work with those agencies directly. What we are is a layer in between that helps facilitate that. So we work with those kinds of agencies if there's audit reports and things like that to let them know how we are protecting their end customer data. Sean, I don't know if you want to add to that, but
Yeah, I guess like it depends on what you mean by agency here. But I think ultimately the question is around, do the access roles get complicated? Potentially depends on what you're trying to do, but I think that for the most part, they're probably not going to be super complicated because really a lot of the rules and engagement around PII is fairly is a lot of times like fairly simple if you essentially apply this pattern. It gets complicated when you're sort of intermixing data sources and then you have to do it in different places, applying different types of rules depending on the like sort of bespoke technology that you're using. That's why it gets complicated. In terms of reports, I mean, you can essentially build your own report based on using our management APIs to pull in if you wanted to know like what those policies look like. And there's also robust like audit logging API as well. So every access, and this is one for compliance and also, you know, just for good sort of security posture, everything that you do in the vault essentially gets logged. And essentially you can pull that in through APIs. And that also allows you to potentially apply anomaly detection tooling to that as well to see like, oh, suddenly, you know, Ashley's role and user is accessing like a ton of records, which is different than his usual pattern of behavior. Maybe I should investigate that. All right. All right. So I'm going to jump into another demo here.
Okay.
Let me just share my window here. All right. So I'm going to start with some slides just to kind of set up the demo, and then we'll get into the details. So this demo is for a company called Instabread. And what Instabread is, it's a little bit like Instacart, but for only delivering bread. So it's a B2B marketplace for bread enthusiasts to get bread delivered by gig workers. And this is a company I made up. So if you look inside the App Store, you're probably not going to find this, but maybe this will be my next startup. And so essentially what we're going to be looking at is the gig worker or shopper's sign up experience. So they need to sign up into this app, and we're going to go through sort of how that was built, and then how would you build a sort of, you know, sort of a modern application that we are probably all familiar with these types of applications using the Vault pattern and architecture, while also leveraging other tools like DynamoDB and Snowflake and Kafka and so forth. All right, so the things that we need in terms of requirements is it needs to be mobile first because shoppers on the go. So we want like an app experience. We have PII collection. So essentially the shopper needs to be able to share their identity information, like their name, email, so on. They also want to be able to select which locations they're willing to travel to for like the bakeries or the shops that they're going to travel to, and banking information so they can actually get paid. We need to be able to pay them. And then finally, we want to use, you know, modern analytical approaches. In this case, we're going to be using Snowflake for warehousing so that we can, you know, essentially learn from the shopper behavior and, you know, hopefully from our buyer behavior, and build a, you know, a bigger, better business. All right. So the stack is front end is React. And then the back end is Node.js. I'm using DynamoDB for application storage. And then of course, Skyflow for data privacy vault. The warehousing or data cloud here is Snowflake. And then we're also using Move. Move is a developer platform for doing money movement and other sort of financial transaction stuff. So that is essentially, we're doing a secure integration and secure data sharing to Move in order to facilitate the payment of our shoppers. All right, so let's go over to my demo here. All right, so this is Instabread. So we're gonna go ahead and sign up. And I'll put in Sean Falconer. We'll do Sean Falconer at Skyflow, 94 there. And then we'll 22, there we go. There's my phone number, and we'll create an account. So normally what would happen is essentially, you know, that data as we saw in sort of some of the slides I was showing earlier, would flow downstream, and we store that in our application database and so forth. But what's actually happening is that data is going directly from the front end securely into our vault here. So if I refresh this guy, here we see now the singular record where we have, Sean Falconer, it's partially redacted, but we can tell, it's Sean Falconer in this case, as well as some other information here. And then if we look at Dynamo, which is what we're using for our application storage, here I have a representation of the record, but it's actually been tokenized. So the first name, last name in this case are being tokenized as UUIDs, same with the phone number, the zip code. And then I'm using a format preserving, consistently generated token for the email in this case. And then we can even go over to Snowflake here and look at our content here. And what I have here is a JSON object stored in a table with essentially the same tokenized information. All right, so, and we'll get into the details of how that's kind of working, but all right, so let's continue here. So shopper's got to be 18 years plus of age, able to lift 40 pounds, eligible to work in the United States. They got to love bread, who doesn't love their carbs? So I meet those requirements. And then I'm going to select where am I willing to shop? So I'll say Safeway and Lucky's, hit continue here. And so that's a good example essentially of something that is kind of sensitive information, but not necessarily regulated information, because I'm probably going to select places in my neighborhood to shop at. And I might not, it says something about, where I travel to and also the location of the city that I live in. And I don't necessarily, as, the Instabread CEO, want that being potentially leaked to anybody that, could potentially listen. So we're storing that here in the vault as well. So you can see that information here. All right. So then we'll go back and we'll put in our account information. So we're just going to store our bank account information, set up the direct deposit. And now, so what happened there was we stored that again in the vault here. And then if we look in Move, let me refresh this. This data was also securely shared with Move, so I can see this bank account information here that was just created. And then let's go back to Instagram. So congratulations, I'm ready to shop. So I go to my home screen, and through the magic of the demo experience, I've already earned $64 from delivering delicious bread to various people. Even got some tips in there, so I can cash out. So I'm going to request that I get paid from Instabread. And then, so it says that now it's going to be, arriving in my bank account. And if I go back to Move, look at, this is Move's admin dashboard. So this isn't like something that anybody be interfacing with, except for like the people kind of setting this up. But I can see here that now there's a $64 pending transaction from the Instabread source account to my account that I just set up. So I was able to do all that stuff essentially without, in a privacy safe way. And even if I go back to something like what we have here in Snowflake, I can also, because I'm consistently generating these tokens, as I mentioned earlier, like there's nothing stopping me from running certain analytical operations on these. Like I could still do, if I had a bunch of records in here, a group by the zip code to find out what is my shopper density by zip code, or if I was collecting state, similar types of things, because I don't need the actual raw information to know that. But if I need to reveal certain information in order to generate certain reports, because we support integration into Snowflake, here we go, then I can actually re-identify the data directly from Snowflake. So we'll go ahead and execute this query. So I'm running essentially the Skyflow re-identify here, and it's going to pass in this case, the tokenized version of the email, and we'll get back the Sean Falconer in this case. So I'm getting that back based on sort of the policies that are in place. They're connected to my actual account in here. All right. So let me just go through, let me just check if there's questions. If not, I'll jump through sort of how some of this stuff's working. So what's happening is from the front end, like we talked about earlier, we're moving that data directly into the vault immediately. So from the application front end, instead of passing that downstream, we're passing it directly into the vault. And then from there, the vault is generating these like tokenized versions of the records, depending on how we've essentially configured that vault to generate those tokens. Then we're passing, well, in this case, we're sending that data securely through Skyflow to move. So whenever we want to talk to a third-party service that needs access to this PII, instead of calling the service directly, we can call our vault with essentially the de-identified forms of data that the third party needs. And then the vault can securely share that with the third party. And we'll take a look at kind of what that looks like. But essentially, the vault is acting like a proxy to the third party. So similar to like when you call your Uber driver and you see a phone number on your phone, it's not actually the Uber driver's phone number. It's a proxy to the real phone number. And that way, they don't have your phone number. You don't have their phone number. So no one's compromising privacy in this case, but you're still actually able to do the thing that you want to do, which is talk to your Uber driver. So we can do that essentially with sending a text message, an email, in this case, doing money movement operations or creating an account on Move. So now we pass that data down to DynamoDB. And then the ETL pipeline here is I set up a Lambda function that triggers whenever new data enters DynamoDB. That takes the data from Dynamo, writes it into a Kafka broker, and then there's a Kafka connector natively within Snowflake that writes that down into our Snowflake table, just like we saw. So we end up with these JSON blobs or records within Snowflake. And we could go and essentially modify them there into more of a tabular structure if we wanted, but Snowflake also facilitates working directly with JSON data. So we've essentially taken all this stuff, kind of like we de-risked this entire surface area by doing this. And then on the query front, what I showed was running something similar to this, where we want to be able to pull in, under certain circumstances, the underlying data to generate certain reports, and do so essentially applying the policies that we have in place based on who this person is. So we can give essentially our analysts enough access to the data to perform their job, but not necessarily access to all the data. So here they can run a query like this, and essentially that query behind the scenes is making a REST API call directly to Skyflow. And then Skyflow is sending back, in this case, the detokenized data. And we're revealing that data based on how those policies are set up, just like we saw in the earlier governance demo. All right, I'm going to stop there.
Yeah, I just wanted to throw out there for anyone that's just joining us, this is AWS Howdy Partner. We are here with Skyflow. We've got Sean and Ashley with us today. They're going over some of Skyflow's data privacy vault. Really interesting, cool stuff if you're into data privacy. So welcome to the show if you're just joining us. Throw your questions in there. We're happy to answer them. And then at some point, you're going to start seeing me throwing in links for our survey. Please take our survey. Let us know how we're doing, what you want to see more of, and all that fun stuff. So,
yeah. And I will say that even if you're not into data privacy, the nice thing is that you don't need to be to basically get essentially this out of the box. Like, I mean, that's like the advantage of using a payment service provider like Stripe is I don't want to have to worry about PCI compliance. I can just offload that to Stripe. But the downside, of course, if I use Stripe for doing that is it's hard to leave the platform. So I can also essentially move those credit cards into a vault and then sort of facilitate payments through the payment provider. But all right, so I guess while people think of questions, let me just show one more thing that I talked about. Let me find here we go. So one of the things I mentioned was secure data sharing. So what I've done here to facilitate that Instabread demo to create an account and move and also do the bank transfer is I created what we call a connection or a Skyflow connection. And essentially you can go ahead and you can add a connection and to pretty much any third-party API. So we provide a bunch of defaults for common connection points. So a lot of people connect to payment providers in order to store their credit cards within their vault, own the data, and get PCI compliance, but then facilitate the actual transaction through Stripe, Adyen, or whoever, or even a combination of those. But you can also start from scratch where you can essentially define the connection configuration, where you're just putting in essentially, what is the outbound URL of the API? How is that being routed? So if we look at, let's see this, if we go back to the HubSpot one here, and we edit this, here, like the base URL is api.move.io, and you're creating essentially these path endpoints based on the API specification, in this case of Move. So everything looks exactly the same. Like the payload that I'm going to send to the connection API endpoint looks identical to what I would be sending Move directly, except I'm just using these de-identified versions of the payload rather than the raw data. So I'm sort of insulating myself from seeing any of that data, and you can sort of see what a sample request looks like and stuff like that here. So I'm here.
Yeah.
This is basically the payload. So
I think
again,
that's the beauty of Skyflow connection. So you don't have to necessarily modify any payloads. You just basically send it exactly as your third-party service expects it. The only difference is instead of the credit card number, you'd be actually sending us the token, which is a pointer to the credit card number in the vault. And on the way out, we just replace that token with the actual value. And then we forward it to the third-party service as is. So that way, I think the benefit to you as a customer is your backend service is not storing that credit card information, but you're still enabling the transaction of payments through your product and your platform. I think this is a very common pattern we see with a lot of our fintech customers. So by deploying this pattern, what you're doing is essentially your backend services you're reducing the PCI scope, which is basically you're not storing any sensitive data there. So the amount of controls you have to put in place are not that stringent. So,
yeah. And do you want to talk about where functions come into play with some of that stuff too?
Yeah. So I think it's interesting. So why we build out this product, it helps in most of the use cases where the third-party services are expecting standard JSON payloads, but I think over the history of the company, we've integrated with over 50 different third-party vendors, and there are some complex integration scenarios where some third-party vendors expect you to concatenate your PAN number, which is a credit card number, the expiration date, encrypt it. So we saw a lot of these interesting patterns where there was a need for customizing the payload on the way out. And there's only so much we can do with the product where we keep modifying code. So we wanted to basically bring extensibility into the platform. So we launched functions earlier this year, which is built on AWS Lambda. So basically through functions, our customers can author custom Node.js code and host it on this compliant platform in Skyflow. And this connections product can now trigger a function. So basically what you're getting now is through a simple HTTP call, you can also deploy custom code and deploy all sorts of data transformations and so on when talking to third-party services.
Yeah, so essentially it's a way to bring compute into your isolated private environment. So it's not just, it's like a natural extension of sort of some of the stuff that we supply or provide through polymorphic data encryption. Is like, now how can you essentially do all of your type of operations that touch any of the data directly in the vault? So I think like one really interesting customer use case with this is where they're storing pictures of driver's licenses in the vault. So you can store, binary data as well as structured data or text data. And they need to know whether the person is over a certain age. So they want to know, is the person over 21? But essentially, how can they do that without bringing the driver's license picture onto their end and running this? So they have a function that essentially runs OCR against the image, pulls out the date of birth, and then really what they need and what they care about is the assertion of whether the person's older or not. It's kind of like, I think like a simple analogy is the way that we think about passwords today. 20 years ago, people used to store their passwords or customer passwords in like a database in plain text. And then we realized we don't need to do that. It's a bad idea. But the workflow that we want to support with passwords is, was the password that entered, does it exist and match to this user? But we can do that through essentially salting and hashing the password. So we can still facilitate that workflow without actually seeing the underlying data. And we're just kind of applying that idea, but across like all PII that you might be having. All right. Let me jump back here. Is there any questions? All right. No.
I think we have a question there, Sean, in terms of latency.
Okay. Yeah, go ahead.
Yeah, so I think it's a good question, right? So obviously there's extra calls, so there is some latency there, but it's so the good thing about the Vault, it's a globally distributed deployment model. So basically we have spread across 13 or 14 different regions. We keep adding multiple different regions. So we have vaults deployed in Australia, in India, in Indonesia, and so on. So in the APAC region, in Europe as well, we have multiple different regions as well. So basically we try to deploy these vaults as close to your production system. So we minimize the network latency. When it comes to the latency, as when it comes to processing, it's basically within a couple of 100 milliseconds. So it usually doesn't show in the front end experiences.
Yeah, I mean, of course, you're making some extra calls, so there's going to be some, additional latency. But I mean, there's also additional latency if you use TLS versus, not using an insecure connection. But everyone has acknowledged that it's worth using TLS, and you'd be kind of crazy to not essentially do that today. So but it's a minimal essentially cost. And we have lots of large customers like GoodRx move nearly 1 billion records onto their into their Skyflow vault, replacing I think like 26 different servers that they had been running previously with a prior solution. So there's people who are running this at very large scale. But one of the things too when it comes to PII is that there's most of the time we don't actually even need the data. There's essentially collection where we're storing it, and then our internal systems don't really need the real like the lot. There's very few like. I'd be curious if anybody has like a good like example of when an internal service actually needs the underlying PII data versus essentially on egress or rendering the data on an account page or sharing the data or running some sort of analytical reports. So essentially you can use the references in form of tokens just like you would use the raw data within your internal system with zero latency because you're not going to be going back and forth to the vault all the time. I see another question. Can you control where your vaults live? I'm thinking about EMEA. Yes, exactly. So that's one of the big things, one of the big value adds. And I touched on this earlier around the Lenovo use case where they launched essentially a laptop in 20 countries at the same time. 6 of those countries had data residency requirements. So they deployed vaults in 6 different regions, essentially, to satisfy those requirements. And if you look at I actually have this up on the screen here with HubSpot. Like I think HubSpot only supports Europe and in the US as at data centers. Correct me if I'm wrong, but I think that's the case. But people store a ton of essentially customer data in HubSpot. So if you need to do this in Australia or South Africa or other Singapore, like other places that have data residency requirements, then you run into a real challenge because essentially you can't actually keep your customer data in those regions within HubSpot. But you can combine HubSpot with Skyflow to descope HubSpot from seeing the regulated data and still do it in a compliant way and still be able to essentially do all the things, get the value from HubSpot without essentially having to move to make it satisfy data residency. You're just doing it essentially at the vault level. Similar like Salesforce and Snowflake and so forth. Sorry, Ashley, go ahead.
I think for our customers, I think it's also a much more cost-effective way to handle data residency because the other alternative is either you not do business in those regions or redeploy your entire cloud infrastructure in those regions. So going with a vault approach really makes sense because most of the times regulatory concerns only apply to PII or sensitive data.
Yeah, so there's also like if you're doing, for example, like let's take the Snowflake example, and you go in and you basically your region in Snowflake is tied to your account, and you create different accounts tied to these different regions. You could end up with 10 different accounts, and now you can't run global analytics across those 10 independent accounts. Plus, it's just like a nightmare to manage, and it gets expensive too. I see another question: do the region-specific vaults come with pre-configured GDPR solutions?
So our product is very configurable, although it's actually good product feedback. So maybe that's something we can consider in the future. But right now, you can meet all of those GDPR regulations through our existing features. So things like right to forget, right to delete, all of this can be configured via our APIs and policies.
Yeah. So a lot of what we're doing is providing the technology support to meet these different requirements. There's a lot of requirements. Like if you look at like something like HIPAA, there's other requirements that would still be the responsibility of the business. But essentially what you're getting with the vault is you don't have to build in the technical requirements. So like within HIPAA, you have to de-identify 18 different fields. You get that for free with using the vault, but there could be other things that are still your responsibility. All right, so let's go. actually, oh, we were just talking about data residency. So this is a slide that shows how some of that works. So essentially, this is, I think, with if I remember correctly when I set this up with the Snowflake example. So essentially, you could have your front end running in the US, a front end running in the EU, and you're sort of sharding your regulated data into vaults deployed within those regions. And then your application backend is just going to have the anonymized versions of the data. You can still use, in this case, like the same sort of ETL, an application database that I was using in demo, but now everything from the application backend and even is descoped from data residency. All right. So let me see if there are any more questions. If not, we're going to jump into some LLM stuff.
Yeah, this is what I've been waiting for.
Okay. All right. So the of course, like world of generative AI is exploding right now. It's going through, a big hype cycle, and we couldn't have a conversation in technology without, hitting our required AI mentions to make sure that we satisfy that requirement. But one of the big challenges, especially from a privacy standpoint, when it comes to LLMs, is that these models are really designed to learn; they're not designed to unlearn. Which means that if you're using essentially customer data, employee data, or even core intellectual property to train the model, you can't really take it back. It's not like going and deleting a row in a database. So even though in the world of GDPR and things like the right to be forgotten can be challenging if you have the data everywhere, we sort of fundamentally understand that I can go to all these locations and delete it. And it might be expensive and take time, but I could probably do it. But there's no real way to do that in the world of LLM. And there is some research that's into this, but there's nothing practical that allows you to do that. So the most practical solution is essentially to not put the data in the LLM to begin with. And then of course, the natural question comes up of, well, how can I use essentially sensitive, my customer data or my employee data or something like that to train a model, but do it in a way where I'm not leaking essentially the data into the model. So this is something that we have been focused on, and we launched essentially a version of our vault that what we call the LLM Data Privacy Vault back in June that essentially helps you solve this problem. So when we think about how sensitive data can enter a model, there's a couple different ways. The first is model training. So it doesn't really matter whether you're building a foundation model or you're fine tuning or building a RAG model. You're essentially starting out with your data living in some data repositories. These are just a couple examples of sensitive and non-sensitive data. And then you're going to pass that data down through some LLM pipeline to a model training environment. And what we want to do, just like we saw in the early examples, is essentially de-identify that data as early in the life cycle as possible. So we can essentially plug in Skyflow at the head of that pipeline to act like a privacy firewall, essentially, where the vault can actually detect PII and other sensitive forms of data. And you can even configure it with terms that might be sensitive to your company. And the data will be pulled out, stored within the vault, and replaced with essentially the anonymized, tokenized versions of that data. So we're getting this clean data on the other side of this. And then from there, essentially, your model training environment, everything can continue as needed. And we can attach essentially contextual information to the de-identified data, like name and then the token, so that the model knows that is a name, but the model doesn't really care that it's Sean Falconer versus ABC123. It just needs some representation that's consistently generated within the model training environment. So here we're essentially satisfying solving the problem of sensitive data deletion by just not putting sensitive data into the model in the first place. Now, the other place where sensitive data could potentially enter in the model is through inference. So in this case, we could be prompting, we could write something here. This is an example where I'm asking it to summarize a will, and I'm pasting in the will document. Clearly, the will has a bunch of sensitive data in it. And then I'm going to perform inference against the model. I don't want this sensitive data essentially leaking in the model. So again, what we would do is we'd have the vault sit at the head of that, and we're going to identify the sensitive data. replace it with de-identified forms of the data, and give essentially the clean prompt onto the LLM. And the LLM has already been trained or augmented or fine-tuned with this type of data. So essentially, the embedded version of these tokens should match up. And then when the response gets generated, if the response has de-identified data in it, this is where we can essentially apply the policy controls that we looked at earlier to make sure that only the right people, or it allows us to control essentially, who sees what, when, where, and for how long. And this means that, if I'm taking my internal company data and I'm training a model on it, I want to make sure that probably the CEO has a different response and access to the data than, say, someone in customer support or someone in marketing or something like that. And by essentially combining the best the best of essentially PII data management with the LLM, you can essentially bring these two worlds together, where you can actually control and govern access to the data in the responses by using the vault as this the buffer into the system. All right, I'll stop there just to see if there's any questions. This also would allow you to satisfy things like data residency too. All right. Okay, so if we don't have any questions, I'm going to continue with we'll do another demo here. So this demo is a demonstration of the LM stuff that we were just talking about. So what this is a medical health customer support scenario. So we have a bunch of patient data that we've used to create a RAG model to augment a foundation model. And then essentially a patient can chat with the customer support person, and the customer support person can talk to an internal bot that's been trained on the patient data to help them essentially, answer questions. So we need, privacy safe training, privacy safe inference, fine-grained access control, because we don't necessarily want the customer support person having access to everything about the patient, but some limited access. And essentially, we're going to take a look at how that works. So in terms of stack, very similar to what we saw before. Front end is Nest.js. Back end is Django. The LLM stack I'm using a combination of Snowflake, OpenAI, and ChromaDB. And then the data privacy vault is Skyflow. All right, so let's go take a look at the demo here. So what I have here, I have a bunch of patient information. There's a chat history here, and I've opened up the AI assistant. So this is my internal assistant. So I can say something like, what's the patient's name? Pretty simple. And send that on to, and we get this back, patient's name. So we can say what is the policy number? And what we want to do is make sure that essentially this type of information isn't actually going into the model. So what the model is actually seeing is this version of the data. So here, these are all essentially the tokenized data. And I've sort of removed the contextual information just for demonstration purposes. But essentially, the model is seeing this representation of the data, while the user is actually seeing this representation of the data based on sort of the policies that are in place and based on the data that's stored within the vault. All right, so this is a quick demo, and we'll take a look at sort of what's going on behind the scenes. So this is just sort of the application of what we talked about earlier. So in this case, what I did was I took these kind of fake patient records, this is the raw data, and I'm passing that through Skyflow and creating the clean data. And then I'm using the clean data to store the patient records within Snowflake via Snowpipe. And then from there, I'm using LangChain. LangChain has a Snowflake document loader built in. And that is an easy way to essentially transform these Snowflake patient records into vectorized embedded forms that I'm storing in ChromaDB. So this is creating our RAG model. And then on the inference side, to keep PII out, is when I enter a prompt who is John Doe or something like that, I want to make sure that the John Doe name doesn't get leaked in the model. So I'm going to go from prompt to Skyflow. Skyflow has essentially a built-in detect API. This is essentially just showing how it works in using the SDK through Python. But I'm calling Skyflow.detect on the raw data, and then I'm getting clean data back. And then I'm going to grab the vectors from ChromaDB, use retrieval QA from LangChain, and essentially take the clean data and then run the inference operation using 3.5 Turbo from OpenAI, and vectors as essentially the embeddings here in the clean data and get the response back. And I'm not showing it here, but we would pass that response back through Skyflow to re-identify anything that's been de-identified. So pretty simple stuff. We're essentially just buffering all this data that's sort of flowing in and out of the model. All right, I'm gonna jump back here. I'll stop staring at my screen for now.
All right, awesome. Well, thanks for all those demos. Those are really cool. Let's see. Yeah, I thought there was another question. That was an old one. So, yeah, no worries. But we've already answered that one. So, one question I had was: is there anything like any kind of database that is not configurable, that's not compatible, or are you pretty much just anything, any kind of data you plug in there? Are you guys compatible with it?
Yeah, I don't think the database really matters because essentially it's not like the vault is necessarily talking directly to your database. Although you could probably do something like that if you wanted to. But it's really generally like the data is being transformed and cleaned before it's actually reaching a database layer. So all your integrations to your database is going to function exactly as it does today. You're just replacing the plain text data with essentially this de-identified forms of the data. So the places that would change the most is wherever you're doing that integration, whether it's at like, front end collection, API gateway collection, ETL layer, like a lot of times, depending on how complicated the infrastructure is, someone might start further sort of to the right than data collection because there's just too many, like that's the sort of most invasive place to start. So if you have a really complicated system, you might start sort of further down the right to where you want to start with, like, let's take our warehouse at a scope. And then you'd move sort of left over time upstream. But Ashley, do you have anything you want to add?
Yeah, I think we can all, one thing we didn't touch on is we can also store unstructured data in the vault. So not just SSN numbers and date of birth and so on, but also like images, like ID card images and so on. There's a lot of customers using us for that as well. We use S3 behind the scenes for that. And so I think those are some of the different flavors where the vault is used. I think one other area I think we didn't touch on is when it comes to file-based transactions. So with connections, we looked at HTTP transactions, but we are looking at we have a lot of customers that use file imports. For example, in the fintech space, a lot of these transactions happen over SFTP. So we do have a product for that as well. So if you have a CSV file with, like, say, 1 million records or so, we can easily import that into Skyflow using a batch tool. And we can also, given a file with a bunch of tokens, we can detokenize that in bulk and send it externally to third-party vendors. So if you look at like how ACH transaction works in the fintech space, or Metro 2 when it comes to credit reporting, these are sort of these SFTP-based transactions which we enable with the vault as well.
Yeah, I think, based on what Ashley was saying about the files, like we have I think an interesting customer use case where they're in sort of the finance space with very, wealthy, essentially, customers. So clearly, like, privacy is really, like, of the utmost importance. And their customers can upload, various files that are, highly sensitive. It could be like their financial records or something like that. So they're storing those within the vault. But as an additional thing, we also do like automatic virus scans on those, so that not only are we making sure the data is secure, but we're also making sure that nothing sort of nefarious is happening with the file, or like something that happened on the person's machine and then they upload it to the storage, and then that leads to a problem.
And so, if someone wanted to get started with using your product, is there do they go to your website, or is there a certain place where they can just start getting exposure to your different products?
Yeah, so you can go to skyflow.com and request a demo, and essentially talk to somebody, and you can get an account and build out a proof of concept.
And I did see that you are on AWS Marketplace, so
yeah,
that's awesome too.
Yeah, so that's another place you could go, is essentially contact us through the marketplace as well. Awesome. Any other questions? Ashley, anything that you think we missed that we should chat about?
I think we covered everything from a product perspective, at least at a very high level. I think it might be good to at least talk about the kind of customers we serve in different areas. So I think fintech's a huge space for us. You see a lot of fintech customers using us. I think the core challenge, what we see there is, say, for example, you're a fintech startup, maybe you start integrating with Stripe, right? And then you get to a certain volume where Stripe may become too expensive for you, or you may want to support multiple different payment services vendors. So in that case, just storing credit card information with Stripe doesn't make sense to you. So then using a vault like Skyflow makes sense, because then you can migrate all of your credit cards into Skyflow, and then from there you can connect to multiple different payment services vendors. So that's a very common pattern we see in the fintech space, especially in underserved regions where you may not have the best connectivity when it comes to different PSP options, payment services options there. I think that's one emerging area for us. I think health tech is a big space for us as well. So when it comes to HIPAA data, I think there's a company that's using the LLM solution for exactly that. They're building a model using healthcare data, but they want to make sure that the data set that they're using to generate these LLM models are HIPAA compliant. So we're helping them redact all sorts of PII data from those from that data set. And some of that data set also includes audio files. So you can only imagine the complexity of redacting information from audio files as well.
Yeah.
So,
also doctor's notes. Yeah.
That sounds complicated.
Yeah. But I mean, that is, there's a tremendous amount of value in that kind of data. I think, there's a lots of anybody who's dealt with the U.S. healthcare system, I sure can tell lots of war stories around, inefficiencies that exist. But so anything that can be done to, speed up care, get, better results, get the information that you need is tremendously valuable. But then you're also dealing with highly sensitive information that needs to be handled very carefully, and there's a lot of trust involved. So you need to be, doing this sort of from day one and thinking through all those different scenarios so that you can do this in a way that is going to be privacy safe. And I think where a lot of people are getting stuck in the world of LLMs is, how do you move beyond sort of demo and proof of concept to something that's actually productionized? If you don't really have a way to solve some of these problems when it comes to trust and safety and privacy with your customer, then that I think it's gonna be very hard to move beyond that demoware stage.
What would you say is the time to get up and running on Skyflow? About
You
how
mean
long?
like for implementation wise?
Yeah.
I mean, it varies greatly. We have, and it also depends on like the use case. So we have people who are doing, credit card vaulting and then sort of orchestration, the payment service providers. There's people who've done that in less than a day or two from proof of concept to going live in production. But if we look at something like GoodRx, where they're significantly large company that also had to migrate from an existing solution of nearly 1 billion records, they did that in under 3 weeks.
Wow. Would you say that like the companies using Skyflow, are they more proactive or are they reactive, like coming to you after something's happened and then save us, Skyflow?
I think there's a mixture. If you look at the, especially some of the companies in like the health tech space, like, Nomi Health was one of our very early customers, and they kind of knew that they were going to be doing payments, they're collecting patient data. And the CTO of that and founder of that company was the former CTO of Goldman Sachs, and actually they're one of the companies that pioneered this approach of the PII data privacy vault. So when he, talked to our co-founder and CEO, Anshu Sharma, he was like recognized it and was like, look, I don't have to build this thing again. So they built that in from day one and essentially part of their like core infrastructure, the same level as like their application database and so forth. And then if you look at the use case that Ashley was talking about, where they're using audio files and text doctor's notes and stuff like that to train this LLM based on patient data and doctor's data, they knew from the get-go. But I think there's other people, companies that have probably been around longer that want to either now prioritize this because they had some sort of issue, or there's also just, I think, a transformation that's happening right now, both from businesses because things are getting more regulated, and there's also these breaches aren't going away, but also consumers are more aware of what companies are doing and more concerned about what companies are doing with their data. It's not like 10, 15 years ago. I think consumers are a lot more knowledgeable too, which puts pressure on companies to do something. And I think that people are more reluctant to sort of trust people who aren't doing the right thing, or they suffer a data breach or something like that.
Yeah. I think also data residency is a big market pull for us as well. So as companies want to expand and offer the solutions to new markets, then they often reach out to us to help them with that transition as well.
Yeah, like the Lenovo use case I mentioned a couple of times, like they went up and running in a matter of weeks as well, because it basically sped up their go-to-market. So there's a lot of places where this might like significantly speed up what you're doing. And then I think once it's in place, it actually can speed up implementation time, because you kind of have this pattern of behavior in terms of how you're going to manage PII. It's not like every time you need to be thinking about, oh, what am I collecting? Where am I putting it? Run it through the like the compliance team. Like you have this pattern in place where you can essentially have every company, every engineering team applying the same sort of pattern of using PII and sharing it and so forth holistically across the company. Because I think what we see in large companies is that each team ends up in solving these problems in different ways independently, and that creates a lot of problems. And then the person leaves the team and the bespoke solution is no one knows how it works anymore, but it kind of works. And I think that's also sometimes where we see companies make a misstep, because if the system isn't broken, someone might not be looking at it, but it might not actually be privacy safe. And then someone figures that out down the road that's a bad actor.
I think that's the core value of what we offer, is this concept of isolation, right? So if you didn't do that, the alternative is you have the PII sprawl problem, as Sean mentioned initially. So you say you're using 10 applications, you have sensitive data spread across those 10 applications. Now imagine you have to launch to another region, say in Europe. You have to figure out how to solve the sensitive data problem across these 10 applications for Europe. It also involves deploying these services in those regions. So if you use a vault architecture, now the vault take cares of that situation for you, so you don't have to worry about that. So it really helps with the data privacy regulations that we're seeing in the market right now.
Awesome. I'm going to get to a question here in the chat from GoCloud1. It says, I'm new to the channel. Is this session geared toward cloud architects or cloud engineers? Great question. It's a mixed bag for this specific show, especially. We cover a lot of architecture. There's a lot of maybe code snippets. Some shows might have a little bit more architecture side, whereas others might be a little bit more. Specifically, Howdy Partner is geared towards anybody that wants to see what AWS partners are doing and maybe learn a little bit about cloud architecture in the process. So good question. Thanks for that. But yeah, it's a mixed bag. And yeah, I mean, I guess there's no other questions. Did you guys have anything else that you wanted to put out there?
I would just say last couple of things. If you're interested in learning more, check us out at skyflow.com, or you can also find myself on LinkedIn. I'm happy to connect and chat. Or if you have questions that you want to ask me directly that you don't feel like putting in the comments here, or you think of later, I'm always happy to respond there. And then I'll be at AWS reInvent at the end of the month, so you can track me down there or reach out if you want to connect in person.
Yeah, I saw that Skyflow is going to be at reInvent, so have fun there. Yeah, it's going to be awesome. So this is usually the part of the show where I would plug the next show that's coming up, but we're going to be taking a break for a bit, I believe. We don't have anything on the calendar for next week. I think it's because of the holiday. And then the week after that is reInvent. So we're not going to have a show that week as well. So it looks like our next show will be December 6th with Zymbit, Zymbit, Zymbit. So yeah, come back and see us then. And I mean, thanks for joining us, Sean and Ashley. You guys had a lot of cool demos and a lot of cool stuff. I'm really excited to see where this goes and, reinvent, have fun there. So,
Yeah,
but
thank you so much for having us. It was a lot
yeah,
of fun.
Good. Blessed.
for sure. Well, thank you, everybody. We'll be seeing you. We're going to go off. Y'all take care.
Bye, everyone.
Bye.
There we go. How was that?